Hello, and welcome to 5 Minutes of Postgres. My name is Lucas, and today we're going to talk about network latency, how it impacts your query performance, and how to improve it by using pipeline mode or copy in Postgres. In this blog post by Lawrence Jones, he describes an issue that he had run into back when he was working at a company called GoCardless a couple of years ago. They were migrating from IBM SoftLayer to Google Cloud, and as part of this migration, they also had to migrate their database. And of course, if you're a payments company, it's very important that you have high uptime, and any migration of that order of magnitude is really hard to do and hard to do safely. As part of this migration, part of the application would be on Google Cloud, but the database would still be running on IBM SoftLayer. That, of course, has a lot of implications around latency. They measured around 0.5 milliseconds when they were accessing the database from within the SoftLayer data center, going from a local application server directly to that database in the same data center. Versus if they went from GCP to IBM SoftLayer, then that would actually take 10 milliseconds, which is a lot slower. This is a challenge. This is really a problem with what Lawrence calls a chatty, or Ruby on Rails in this particular case, likes to treat the database as if it can just make function calls, like the database is just sitting next to it, being able to answer questions at any time. They were trying to determine how can they support a higher latency, at least for some time. They ended up doing testing using a tool called TC, short for traffic control, in Linux. TC adds a latency to network packages. You can simulate a slow network like they would have when they go across clouds, then they would simulate it on the Postgres server itself. Over a period of a week, they would keep adding 1 millisecond of latency until they got to 10 milliseconds, and they would try to see what falls over. And of course, they saw various issues happening. They saw long transactions causing problems, certain requests taking too long. This is a really good practice if you're trying to simulate what would happen if you didn't have the application database sitting on the same network. If you want to know just the raw timing, one useful tool in pSQL, the Postgres client, is to use Backlash timing. Backlash timing tells you the measurement of time as seen by the client, not as seen by the server. You turn it on, you run a query, and then it gives you the time that that query took from the perspective of pSQL. Notably, as described in this mail that was drafted about 10 years ago, the timing command shows you the total time it took to execute a query and fetch the results back to the client. If you run explain analyze, for example, explain analyze also shows you execution time, and that's actually output by the server. The server summarizes how long the query took, and so explain analyze will not include this round trip time. If you're doing performance benchmarking, be sure you know what you want. Do you want the network latency included? Then backslash timing is good. If you don't want network latency included, then do some method of collecting the server-side time. Let's say you want to improve how your application works with network latency. The first thing to know is if you're doing a lot of insert statements, doing individual inserts can be really bad for performance. Let's say you're doing a loop and you keep inserting new data. If you're doing all these individual statements, the client will have to wait for their query to complete. You have all these round trip times as the query executes, and the next query executes, the next query executes. That takes a long time, but really you're just waiting for a network. The alternative to this is using a copy command, where you're just continuously sending data to the server and you're not waiting for the results. It's much more efficient from that perspective. And there's also other aspects that benefit from copy. In this example, copy was more than 10 times faster than individual insert statements. The other thing to know about is pipeline mode and libpq. This was added in Postgres 14, and it was added to the client library. You don't have to use Postgres 14 on the server, but you have to make sure that you use a new enough client library on the client side. If you use libpq 14 or newer, and your programming language driver that usually uses libpq supports this as well, then you can use pipeline mode and libpq. Here's this useful blog post from Cybertech 2 years ago, where they describe the client sending commands. If you don't have pipeline mode, what happens is you send a query, result comes back, isn't the next query. Versus if you use pipeline mode, you're sending a query, and then before the result comes back, you're sending the next query. There's continuity of queries being sent, and then you are waiting for the results in order. You do have to be smart on the client side, but it does allow you to queue up multiple commands to be processed. And so this is something that you could use to work around higher network latency, or just in general to increase the system throughput. Thank you so much for listening. This was 5 Minutes of Postgres. Subscribe to our YouTube channel to hear about next week's episode, and talk to you next week.
you.